With runtime PCG finally introduced in 5.4, we can now do things like having a fully procedural forest and having something like ores where you can pick them up, and as they kind of get taken out, it goes ahead and regenerates the forest in that area as though there was nothing. And after some time, as you're gathering these, it can go ahead and regenerate the entire thing and pick new locations and new ores to spawn. So you can go ahead and pick them up again, and again, it will always regenerate them. So this way, in your game, as you're picking up things, it will automatically get filled in and make it nice and clean so you don't have big empty areas like this. And this is what I'm going to be showing you how to do and set up today. Let's get to it. Now, I am going to be starting with this PCG forest that I've created here. It is not imperative that you use this, but if you want to use this as well as learn how to use some other runtime stuff, I have a tutorial for it right up here where I go ahead and create this in the last video. But the general idea is all it is a spline sampler with some points, and I cut out a platform for myself that I was using to actually respawn the forest with, and it's just spawning some trees and some little bushes. You take a screenshot of this is all it is. But to get started, what I'm going to do is start by creating the actual ore system and the blueprint that is going to go ahead and allow us to interact with it, and we'll take our ores and make them smaller and smaller until they eventually disappear. So I've gone ahead and brought in my ores, which are these ones right here, and I have a link to them in the description below if you want to grab these for yourself. I just made them regular default materials, but I believe there is an option to download them with a few extra textures. And effectively, I have three versions: a blue one, a purple one, and a red one. And so what we want to do is when you interact with one, it goes from the largest to the smallest, and make sure that it's always the blue one, the purple one, and the red one, respectively. So to do that, what we're going to do is set up some things, starting with a struct or a structure that is going to hold our actual static meshes for each one of these. If you're unfamiliar with structures, think of it as something that is holding a lot of different variables. And you can have variables inside of variables inside of variables. We're not going to go in that deep, but just imagine it is a container for variables, sort of like a blueprint. So what we can do is right click, search struct or structure, and you want to grab that, and I'm going to go and call it S-ors. I'll go ahead and open it up. By default, you should see something like this. What I like to do is take my default values and just put it right to the right side, so I have them side by side. But effectively, you set up the variables here and their defaults on the right. So what I'm going to want to do is I want to make actual 3 static meshes. So I'm going to left click on the Boolean, search static mesh. You want a static mesh object reference. And you can see it has changed on the right here. And this is going to be our large. And we need 2 more, call the second one medium and the last one small. Again, all 3 are just static meshes and they can be blank by default. That is fine. So that's all we need here. Next up, we need the blueprint that actually is going to spawn the ores and control all the other things with it. So I'm going to right click and make a blueprint class. It's going to be an actor, and this is going to be our BP ore. Now in here, we're going to need a few things, starting with a static mesh actor, because the static mesh is actually what's going to be spawning our ores. Now, in my case, the actual scale of these ores, if I go into assets and bring out, for example, this large blue one, is quite small. I want them to be considerably bigger, and I'm thinking of just having them 3 times bigger so we just see them right away. Of course, it depends on what asset you're using, how big you want it, etc. But for me, I just want it to be 3 times bigger. So in our BP ore for the static mesh, I'll just set the scale to be uniformly 3 times the asset size. And now we're going to need a few variables, starting with a struct that we created. So we'll create a new variable, and this is going to be our ore selection list. And the type, instead of Boolean, is going to be our S_ors. And here it is. You can just select it. And what we want to do is convert to an array because we want all the different kinds. So I'm going to right click on S_ors and it'll convert it to an array. And now if I go ahead and compile it and select it, you can see here on the default value on the right, we have the ore selection list, and I can add a new array and open it up, and we have large, medium, small. And I can go ahead and add 3 arrays total, which will allow us to input our 3 versions, which I'm going to go ahead and do right now. So here it is. I've populated all of these in. So now we can grab between each of the things in the array and which version it is. So with this all done, let's go to our event graph. We're not going to need event tick or event actor begin overlap, so I'm going to delete them. And on event begin play, I want to grab one of those ores from here and spawn it in. So I'm going to take our ore selection list, hold control to get the get node, and then I want to grab a random one of these, random array item, and I want to make sure I know which one it has gotten, so it's always consistent. So I'm going to right click on it, promote it to a variable, and I'm just going to call this selected ore. Plug this in from the begin play. And now we want to use the selected air to spawn the static mesh. So if I grab our static mesh and I go ahead and set static mesh from the static mesh component, you can plug this in. And for the new mesh, what we can do is grab from the selected ore and search for break to break the actual ores. And now we have the individual things. So we want to make the large ore the default. And if you'd like to, with it selected, you can hide unconnected pins and you'll just keep large there, so it's just a little bit cleaner. And the other thing we need to know is which one are we actually looking at? Because right now, we don't have a record of which ore it is. Are we looking at the large, the medium, and the small, etc.? We don't know. What we can do is basically give ourselves a value, and based on that value of what we're using, it will update. So I'll add ourselves a new variable. This is going to be our ore phase counter. And instead of S ores, it's going to be an integer. I'm going to right-click to convert it to a single, and it is just going to be set to 0 right at the end here. So if I go ahead and compile this, if I wanted to, I could already take this BP ore, place it in the level, hit play, and you can see here it is. Here's our ore. And if I play again, there's a different one. And each time it will pick a random one between the three. So that's now all working. Now, I'm going to be showing you one way of doing this. You can do it, of course, in many, many different ways. What we're going to be doing is walking up to the ore, interacting with it using an interface that we're going to be creating. So that way it can be used on many different things, not just the ores. And then it is going to shrink them. And once it has shrunken completely, it fills in the thing. And then after some time, it regenerates the entire thing random. You can, of course, have it regenerate when there's only a certain amount left or a certain other criteria. It's entirely up to you. I'm just showing you one way of doing this and kind of opening the door to you to figure out which one you want to implement into your own system. Now that you know kind of the basics of how stuff like this is done. So now to start actually setting up the interaction, what I'm going to do is create an interface. As I mentioned, I'm going to right click and search blueprint interface. And we want one of those. And I'm going to call this BPI underscore interactables. I'll go ahead and open it up and we're presented with this menu. The first thing we need to do is just give it a name, and I'm just going to call this interact. We can, if we wanted to, push inputs in and have outputs. If we want to have some kind of control over sending or receiving variables, in our case, we don't need to. We just need to implement this function to basically trigger on whatever we set up. So go ahead and compile this. This is all we need in this interface. And now in this BP ore, I'm going to go to class settings up top and the right implement an interface. I'll go ahead and click add and search for BPI interactables and go ahead and select it. And now you can see on the left here under interfaces, we have interact. If I double click on the interact, we get the event interact. So whenever this triggers, we can now do something with it. And what we want to do is every time we interact with it, it needs to set a new static mesh based on which ones we have available to us. And we, of course, need to update our face counter. So let's start with updating our face counter. At the very beginning, I'll grab our face counter. I'll incrementally increase it by 1. So it's going to go from 0 to 1. And then I want to check if it is the actual final one or not. Because once we have actually gone through every single ore, the big, the medium, and the small, we want to just delete that actor. There's no reason to keep an empty set here, so we want to delete it. So we can go ahead and check that it is less or equal to 2, or we can just do less than 3. Either one will work. So if we do less or equal to 2, and the reason we'd be doing 2 is, again, because it starts at 0, then goes to the medium one at 1, and the small one at 2. So as long as it's successful, it's one of the correct ones. It is going to be less or equal to 2. And if it is, we're going to set it up with a branch. We want to set the static mesh. We want to do kind of the same thing we did here. I'm going to duplicate this over under true. And instead of plugging this in directly like this, on the static mesh, I'm going to drag out of here and use a select node. And I want to select it based on this ore phase counter. So I'm going to duplicate that over and plug it in. And it has now selected option 0, option 1, and we actually need another option, option 2. Because again, it goes 0, 1, and 2 for us. Now, we can plug something in here manually, but that's not what we want to do. What we do is grab our selected ore here on the left. Then we can do right click and split struct pin. And now we have our large, medium, small, and we can go ahead and just plug these in straight through. So now at the very beginning, it picks a random one of them, it stores it, and then every time we interact with it, it will go ahead and set the next one in line. Now, assuming that it is actually now has gone past the final interaction, we want to go ahead and remove it. So assuming that we have interacted with the small one, we have gotten it. Under false, we just want to get rid of this. So from here, I'm just going to do a destroy actor. Now, this is great, but the problem here is we don't actually trigger this event interact just yet. So let's do that, and we'll do that from our player character. So here I am in the default third-person character blueprint. And all we need to do is create ourselves a new input. Now, you should be setting it up with advanced input in mind for your own setup. In mind, because I'm going to be showing this just as a tutorial, I'm going to be setting up with just a simple debug key. But again, for yours, make sure to set it up with the proper advanced input actions. So for my setup, I'm going to go ahead and right click. I'm just going to search for debug key E and go ahead and select it. So whenever I press the E key, this will trigger. And what I want to do is basically do a simple sphere trace around me. And as long as I'm in the right area, it'll go ahead and interact with that object. Now on press, I'm going to do a sphere trace for objects. Now the start and the end location, because I just want it to be around my character, are going to be the same. I'm going to drag out of start and get actor location. I'm going to plug that into the end as well. The radius, I'm just going to do 150. And from object types, I'm going to drag out of here and say make array. And now we can just specify what kind of object do we want to interact with. Now for your system, you might want to do a custom trace channel for your objects. In my case, I'm going to be using World Dynamic. Now, if you're wondering how do you know what to use? By default, World Dynamic is immovable objects, and static objects are going to be World Static. So if you have something unmovable, it'll be World Dynamic. And if I go to BP ors and I select my static mesh, it is movable. And if I search for collision, you can see object type World Dynamic. Now, by default, I'm using the actual template floor that spawns in the ground, but it is also movable by default, which means it will also trigger. So I'm going to set that to static so it does not get triggered by this. But if I wanted to, I could create, again, a custom object trace channel, and then I'd be fine to do that specifically for the ors. But now that we have this, what we need to do is check if we hit something, get this return onto a branch. And assuming that we have, let's get our out hit, and we can break it. And there's a lot of things here, a lot of information, but we just want the hit actor. What did we hit? If we grab out of this hit actor and search interact, under BPI interactables, you see interact message, and that's what we want. Go ahead and select it and plug this into true. So I can close this, and effectively, assuming that this hit actor has this interface and it is doing something with it, it will send this information through to that object. Right, here's our OR. So I can come here, I can press E, and you can see it becomes smaller, smaller, and now it's gone. If you're enjoying the video so far, I would love if you hit the like button and subscribe if you're new for more awesome tutorials like this. Let's get back to it. So that's great, but now we, of course, have a single blueprint and we've manually placed it. We don't want that. We want everything to happen automatically. So let's go ahead and set that up. So what I'm going to do is right click and create myself a new blueprint class. And there's going to be a BP actor, and there's going to be our BP or spawner. And inside of it, we just need a few things, starting with a simple spline. And I would like to just generate a big square. So I'm going to take the last point, delete it. I'm going to right click on the first point and go to spline generation panel. I'm going to create a square. I make it quite large of 1,000 units by default. And that should be good. I'll close out of here and I'm going to search for closed loop. Check that on. Now we have a few points overlapping. So I'm just going to click on this point right here at the beginning and press delete. And now you can see we have only 4 points here, and it makes a nice large square. The other thing we need to do is add ourselves a PCG graph. Now we haven't made one yet, so let's go ahead and create one. I'm going to right click and search PCG, grab ourselves a PCG graph. For this, I'm just going to call it PCG or spawner. Let's go ahead and plug this into our PCG graph here on the right. And the only thing else that I want to change is up above under settings for a PCG. Instead of generate unload, I want to generate on demand. So I want to generate it when I want it to generate. So perfect. That should be good here. I'll go ahead and compile this. Now let me put this actually in the level. So what I'm going to do is grab our forest. I'm going to just go ahead and clean up this PCG graph so I can more easily take our BP spawner here, place it in the level, and then actually set it up where I want it. So I'm going to take my points and position the entire thing, cover quite a large area, and that should be good. So now let's go ahead and set up our actual PCG graph. And for that is quite simple. I'm going to right click, get spline data, because we are getting it from a spline. From there, I'm grabbing ourselves a spline sampler. A sampler we're going to be using on interior. We're going to check unbounded. And for the sampling, I'm going to change interior sampling to 500 and interior border sampling spacing to 150. So let's grab ourselves a transform points and let's mess up these points a bit. I'm going to move them from -250 on X and Y to 250 on X and Y. I'm also going to rotate them randomly 360 degrees. And if you'd like to, you could scale the actual ores a little bit up and down. So for example, between 0.8 and 1.2, we can go ahead and scale them uniformly. From here, I want to filter out some points. So I'm going to drag out of here. If I search noise, you get attribute noise and density noise. Density noise is the same as attribute. It creates literally an attribute noise node. It just automatically puts in the density here for you. So it kind of is a one-stop shop for it. And then from here, we want to go ahead and filter those points. So I'm going to search for density filter and go ahead and select it. And I want to filter out kind of most of the points because we don't want too many ores here. So I'm going to filter out 93% of all the ores. So we're going to be basically left with this little sliver of things. And if I go ahead and sample this by pressing D on it, you can see we now have considerably fewer points. Now that's exactly what we want. And now we want to spawn our blueprints. So I'm going to search for spawn actor. Now by default, it throws an error because nothing has been plugged in. Our template actor class is what we want to plug in. I'm going to select our BP ore that we've created. And I'm going to plug this into our template actor class. And there we go. It's been plugged in and the error is gone. Now, currently it's set to collapse actors. And in this case, it's going to basically not work because it is assuming that everything's kind of PCG and it's kind of merging them all into one. We don't want that. So I'm going to select no merging in this case. You could do merge PCG only, but we don't have PCG here anyway, so we can do no merging. You have the option of where do you want to put the files that it generates. In a folder is where I'd like to typically have it, but you can have it attached to the parent if you wanted to. This is just an organization thing. There's also a few other things you can do, like attach your tags to it, have post function names where you can run functions after each one generates, but we're not going to be covering that in this video. This is all we really need for this one. So now from this PCG, if I go ahead and use cleanup and generate, you can see we now have blueprints actually spawned all over the place. And if I hit play, you can see we now have these ores everywhere. And if I press E next to them, they get smaller and disappear, which is pretty much exactly what we want. So I'm going to go to my forest and I want to modify our forest that we had originally had here. If I go ahead and regenerate it to actually cut out the areas for the actual ores we've generated. I'll go ahead and open up the graph for the forest. And I had it originally cutting out a platform, but in this case, instead of a platform, I wanted to cut out all of the ores. Now, if you already had something cutting out, that's fine. You can use that as well. I'm going to duplicate it to get another get actor data, or right click and search for get actor data. And we want, instead of self, to be all world actors and by class. Now, if you, for example, are spawning multiple different kinds of blueprints, you can do it by tag and give them all a tag, and then you'll be able to select all of them that way. It's entirely up to you of what fits your needs best. And the actor selection class, we go ahead and pipe in our BP ore, and we want to make sure select multiple is checked because we want it to grab from all of them. Under mode, it's currently parsing actor components, but really we only care about a single point. We want to just fill in that area, assuming that we have cleared out the entire thing. You can do it by component, and then it will change the size accordingly, again, based on your needs. So now that we have this, I'm going to grab ourselves a simple merge points and merge our original actor data with the new one, like so. So now it is going to cut it out. So if we come here and hit play, you can see we have some ore here, and I can press E to cut them out. And as soon as it actually disappears, it regenerates that area of the forest. As you can see, it is now getting filled in, as though there was never ore there to begin with. Now, as always, the project files are going to be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. Or if you have any questions or comments, please leave them in the comments below, or come join our Discord, where you can join like-minded people like yourself. Thank you again to my patrons, and let's get back to it. Now, this is great, but we still aren't regenerating this area at all after some time. What if we wanted to regenerate, whether it's in the same location or in a new location? Well, that is quite simple. For that, we go into our BP ore spawner, where we have our ore spawning PCG. We can go to the event graph, and we just need event begin play. So on begin play, we can go ahead and create a timer by event. And let's say every 20 seconds on a loop, it'll generate a new one. So from event, I'll drag out and say custom event and say regenerate ores. From here, I grab our PCG node and search for generate. Now, normally you just force generate and that's all you need to do. But because these are actually all blueprint children and not just components, we actually need to do a cleanup first. So for our PCG graph, I'm first going to search for cleanup, and I want to also remove components from this cleanup. And then I want to run this generate. So now with this, if I come here and I go ahead and get rid of these guys all around here, after 20 seconds, it'll go ahead and regenerate these ores that are right next to me. There we go. They have regenerated. They've popped back up in the exact same location. And every 20 seconds, they will go ahead and regenerate. Now, of course, for you, you might want to do it, every half hour, every hour, whatever time frame you would like. But maybe you also want to have them be in a different location. If you want to do it in a different location every time, from our PCG graph, I can go ahead and search for set seed and just a regular variable set seed. And here, I'll go ahead and plug that in before cleanup and generate. And from seed, I'm going to get a random integer in range from 0 to a high number. That should be plenty. And now when I generate them, here are some ores just as before. We can go ahead and clean them up, select them. And as I'm going through and removing them, after 20 seconds, it'll go ahead and generate new ores in different locations. And there we go. The ores just popped up. So now we have new ore that just popped up here, and it's entirely new locations. The old one have not actually been replenished. It is entirely new locations. And again, you can go through and clean it up. And as you go through, it will replenish the forest as before. So just like that, we already have a basic gathering system that now is also dynamic with the environment. And you can go one step further and have it also maybe on a time not only regenerate the ores, but also regenerate the forest itself. So you can have a slightly different layout for the forest, a slightly different layout for the ores, or the terrain, or whatever else you want, and have it all be kind of dynamically linked, but at the same time, all controlled through just simple blueprints and PCG. Now, if you guys are interested, I can go ahead and make another tutorial on how to go more in depth if you want to do things like actually see how many ores are there left, and once only a few are left, then regenerate them after I have mined that last ore in the sequence, then they all get regenerated. You can actually bypass the whole everything regenerating at once and then just create the regeneration in the blueprint ores themselves. So that way, after time, that specific ore just regenerates where it was. But this was more of a PCG tutorial showing how to create that kind of system, which is why I went with this approach. But if you guys are interested in more real-time things, check out this video right here, where I show you how to use PCG, potentially using it as a mob spawner.